Now I'd like to present Rob McMullen and Kevin Savitz on reverse engineering Jumpman. Thanks.
All right. So has anybody played Jumpman? Yeah, I know somebody has. Yep. This is the Atari version. The Apple version is spectacularly bad. So we'll just never speak of it again. I'm not gonna. If you want to play it, play this version. I'll just show you what it's like in case you've not seen it before. It has great sound too. Unfortunately, I can't get the sound going. So here's this little dude, jump around, hence the name, pick up stuff. One of the neat things about it is that actions can happen when you collect things. So anyway. Oh, splat, splat, splat. So, yeah, Randy Glover, the author of Jumpman, he ported this to the C64, and then somebody did the Apple version, but he didn't know who did it and disclaimed all knowledge. So yeah, we won't worry about that anymore. So Kevin and I interviewed him. Kevin was gracious enough to have me along on the interview. As you might know, Kevin does lots of interviews, and we talked to him. He remembered that he did all his coding on the Apple II, and he transferred it all to the Atari for development. He said the development tools on the Apple II were better than what he had on the Atari. He didn't remember how he got the stuff from the Apple to the Atari. I think, well, the Apple, having your own disk controller, you can write a lot of stuff. I don't know, does anybody, can it write FM formatted floppy disks? No? John?
It does. I think we had a output from the card and the TV to the joystick controllers.
That is a common way to do it, yeah. Yeah, so the joystick controllers on the Atari can be used as input and output. So you can run a little program on the Atari and slurp something in and then boot it that way. So yeah, that's probably how he did it, although he couldn't exactly remember. So yeah, so FM format is, so I'm not talking about any copy protection on Jumpman. Jumpman was copy protected. He didn't recall exactly how it was, but so I'm working from a cracked version. So the reverse engineering is totally about the game itself and not the copy protection. I guess it is worth a little bit talking about the disk format. The Atari has a serial port interface to the disk drive. It uses 19.2 baud, but it's much slower than the Apple. Interestingly, I think in one of the interviews Kevin did, he talked to one of the guys. Am I getting feedback somehow? Sorry. One of the guys who was working at Atari. The 2600 uses 6507 microprocessor, which has 128 bytes of RAM. You know, it's very small. They sourced them because Atari was looking for a good deal. They sourced them at a lower megahertz than what the 2600 needed. The ones that failed sourcing for the 2600 went into the floppy controllers for the 810 disk drive. So they ran it, I forget, less than 1 megahertz. But anyway, so the disk itself has a 6507 in it. The Atari talks to this drive, says, I want sector 100. The disk drive goes and gets it, hands it back, and that's all the computer can do. It can't do any of the track manipulation. It can't do any bitstream stuff. All it gets is a sector. So for bad sectors, you can only tell if it's bad. You can do a few things, like you can make a weak sector, like some weak magnetic stuff, or you can give a sector the same number, and so you can read it, and it'll get different values for every time you read the sector. That's about it. Okay, let's see here. Go back to this. So, editing sectors, all you could do is really look at the raw data. You couldn't look at the bit stream. I remember using this kind of stuff when I was hacking on the 8-bits. You know, you can change the hex, you can change the ASCII. Also, a lot of sector editors, I couldn't find the one I used to use, but a lot of them you could see the bit pattern of the bytes, and you could change like the player missile graphics and stuff like that. So this is what you would have used to hack a program back then. When Kevin and I started talking about hacking Jumpman, I said, well, I'd like to have some tool that could hack code kind of in the way I used to do it. So, and so I wrote one because Not Invented Here is like my middle name. Yeah, it's a Python program. It's written in with a user interface toolkit called WX Python. So it's full windowing. It's cross-platform. It's GPL. It's on GitHub. It's available now. I've got some stuff to show. One of the cool things about Python, and there's a numeric toolkit called NumPy, so you can treat data as arrays. It has a lot of vectorized stuff. You can kind of think of it as like a MATLAB sort of clone for Python. And so I've used that to look at this binary data. Now, I'm not a UI UX designer. I kind of like old school stuff. I want to see all the information I can in as least amount of space as I can. So be prepared for a little bit of clutter if you're not into that kind of stuff. So this is the editor and the hex editor that I designed to help us reverse engineer Jumpman. So you've got hex data you can look at. This is the bit pattern I was talking about. So if you look at a byte, it'll show you the bit representation, so you can look at that. There's the text view and disassembly. I wanted to have some way to keep notes as we disassemble this stuff. So there's a way you can type comments in the disassembly. All right, so this is an Atari format floppy disk, and what I've done is I've parsed the format of the floppy disk so you can check things out in what I've called segments. So you can look at the raw sectors, the volume table of contents, the directory, and if I just pick out a random file, let me pick a bigger file. The way Atari formats work, unlike DOS 3.3, which I've learned, is Atari formats have 128 byte sectors. The first 125 are the data. The last 3 bytes point to the next sector in the file. What NumPy allows you to do is allows you to look at data in different views. So different views of the same data. So this is a view of the file only. If I look at it in the raw sector format, you'll see I selected contiguous bits in the file, but there's these little gaps. So it can do multiple selection. You can treat a file, if you're looking at the file view, you can treat it as contiguous. Whereas if you look at it in the raw sectors, it's going to... What file was I looking at? Shoot. This one? I don't remember. So if I do this again, if I select some data, I can change it, change FFs, go back and look at the raw disk. It's left all the other stuff alone. So you can overwrite all the stuff that's in the file without having to worry about the format of the underlying file system. It's got all sorts of stuff for hex editing. You can type in here, change bytes there. You can change bytes in the text. Let's see. I'm showing you all this stuff in the hopes that it might be useful for you guys, not just Apple people, or not just Atari people. As an example, perhaps, the machine sitting next to Kevin's, the Provets, the clone of the Apple II, Quinn pulled the ROM and imaged it, and they were wondering if there was Cyrillic text anywhere. You might notice here the fonts are backwards. That's the way the graphics are stored. The least significant bit gets the furthest left on the Apple. So we can fix that if you want to look at it. So I had to add this little command just this week. I didn't have it before, but we're going to reverse the bits. And so we can just scroll down the bits. Okay, it looks normal, looks normal, looks normal. Got some lowercase. Whoops, whoa, what do we got here? We got some Cyrillic. So there's Cyrillic in that ROM. No. So I will spill the beans on my HackFest entry. This is what I'm doing. I added DOS 3.3 support to Omnivore. So I found a great book of the garage giveaway. Beneath Apple DOS. That's it. Yeah. So I was reading that, trying to figure out how Apple DOS worked. So I've pulled the structure of DOS 3.3 out. So you can look at the raw disk. There's the boot sectors. Look at the volume table of contents. Then you can look at the catalog. So you can. And again, the catalog is, if you look at the catalog here, I've listed it sort of in logical order. If you go back to the raw sectors, it's backwards. It stores it from the sort of the bottom. Where'd it go? I don't know where it went. Sorry, but it stores it backwards, and so you can edit it here in the normal order. And when if you make changes, go back and look at the raw sectors. It'll put it in the right spot. I added blinking text because I thought it'd be cool. It's actually really annoying. So, so I added another font. So I put mouse text in there just so it doesn't flash. So back to Jumpman. So I turned on the slow loading for Jumpman here. Just I don't know if you can see, there's a number there. On other emulators, it'll show the sectors that as it's going. To reverse engineer this, I didn't know where to start. I guess that's the problem when you reverse engineer anything, is like where to start. So one of the easiest places to start on the Atari is the SIO vector. There's only one spot you can go to read anything off the disk, and you have to jump through this certain vector. So we'll load up a raw image of Jumpman and search. So E453 is this disk INV is the disk vector. So I can search, and then here, this is essentially how you define where to read off the disk, this aux1 and aux2, to find the sector number. So there's a few places that this shows up. And so it says, yeah, match 4 of 7. You can just skip through. And so eventually I figured out where there's a boot code that it's like 4 sectors long, which is right there. And then there's the rest of the code. It loads. This is designed for a 32K system, so it started loading at 3000 to 7 FFF. So that's basically how I started. That's kind of my foothold into it, is to figure out where it loaded, find the input vector, the first vector it jumped to after it finished loading, and then jump to there. Another way on the Atari, I don't know, this is not really applicable to Apple, but one of the things about Atari is they have these display lists. So you can search for a common header for a display list is 707070 hex. And you find display lists, find lots of 70s. And so here is if you notice, this is the part of the title screen. And there's the main game menu. So points like this is just how I kind of jumped around in the code and found some spots. One thing I forgot to mention as part of my HackFest. Well, I'd done some of this before, but there's a disassembler. You can see there's also an assembler, mini assembler, and it supports a whole bunch of different stuff. I don't know any of these other than the 6502. 65C02 is what I think do all Apples have 65C02?
6502 and 65C.
And I know the GS has a 65816. I'm gonna do something stupid. Somebody tell me a 65816 command. I will try to enter it, see if it works. I know one, but I've tried this before, so this is a. No.
6502 or 65CO2?
I'm gonna try it. Right now I've set it to 65816, which I don't know, and I'm gonna do something stupid. I know this one. So you can do mini assembler. You can assemble stuff right there if you need to. Maybe that I won't press my luck any further to ask for anything more different. Okay. So this is sort of our fully commented version of Jumpman. One of the things I wanted in an editor, there are other disassembly frameworks. There's one called Radar, which is I think more designed for modern stuff. But it's really big, and instead of spending a couple days trying to figure out Radar, I'd rather spend a year and a half writing my own code. So, and I didn't know if it'd do stuff like this where I can. So as I found stuff, we make comments on the code, so we figured out this is the first level. There are 32 levels in Jumpman, and the way Randy Glover did it was he made it modular. So each level is 16 sectors. You load in a level, and there's a bunch of vectors in the level data itself that you can jump through to set up the level, to do custom commands, to do a whole bunch of stuff. And so he put this big header here, and in it there's some. Let me get rid of the bitmap here so we can see a little bit more. So we put the level number, there's the colors here, and then there's other things like there's a vector to the level definition. So this is what Kevin was working on. As I was kind of getting familiar with the code, Kevin was hacking with the level definition itself to try to figure out how he created levels. And it turns out he uses a little language. So there's, starting here at 2C100, he designed this little sort of bit level language that describes the ladders, the girders, the bomb positions, and some of the callbacks and stuff. So Kevin was figuring this out as I was hacking with the assembly code. And oops. Sorry about that. And my goal with the assembly code was to figure out how to jump to any level, because I hadn't seen a couple levels. That was kind of the thing that was my hook to get into it. So I apologize, I had to add a crack screen because I wanted to make sure people knew that it wasn't the original version. So this was my first hack. I added this. Oops. So now you can jump to whatever level you want. And in this level, this is a fun one, and that shows you some of the stuff that makes Jumpman really unique game is it's got a whole bunch of different levels. It's not it's not static at all. Each level can have different things. It can have, the idea behind what Randy Glover did is he put these hooks in the code, so you could change things, and that's sort of our current stage. Is we're exploring how to do these hooks. And this was his tribute to Donkey Kong, he said. So today we have a KFest exclusive. We are announcing that our documentation is available to the public, or will be shortly. This is 28 pages of all the stuff that we found out. So we're gonna publish this. If anybody wants to start hacking with it, they can. There's a ton of stuff. This is another little hack I wrote. If you want to test a single level, I wrote a little loader that only has a single level in it. It loads pretty slow because I didn't turn off the fast loading. But this is the first level that has been designed in 32 years. Kevin designed it, and yeah, it's not an easy level for sure. But this took Kevin quite a while. I don't remember how long it took you to design this one, Kevin?
8 or 10 hours, probably.
Because all that hex data he was coding. He figured out how to do all the hex, but he had to enter it in by hand, and then it's just a lot of work. A lot of trial and error. Oops! Whoa, stop that! Stop that! Let me go back. So the other goal, I didn't intend to do this. This wasn't my first goal, but I decided that I knew enough about it that I'd go ahead and try to write an editor. So I did. So what this is a fully graphical editor. This is the Jumpman start position, and we can save it. Oops. Yes. And we can test it. And that's where I put the guy. Go down. And yeah, it's
Awesome.
Thank you very much. Yeah, so I am really pleased that Kevin and I were able to get as far as we have. I'm releasing all this. This is all GPL. It's all public. I'm gonna release it, this new version, as soon as I get home and I can build again. There's still a few things left to do with the editor, but it's mostly complete. The next thing to do really is the custom code and how to interface that. And then in terms of the editor of Omnivore itself, listening to Dagan's talk yesterday, I would love to be able to interface this and use sort of all these searching tools and stuff with the output of his emulator, so be able to hook into that and have this as the front end to the emulator, just pie in the sky stuff. But I'm intending to work on this editor for a while. If you have any feedback or suggestions, I'd love to hear it. So yeah, any questions? Yeah.
On the screen where you're drawing out the levels, is there a place in there to bullets that fly in from the sides and top?
No, there is. Let me show you some of that. There is a parameter you can set. Oops. Down here in the level data section. Let's see. So you can change the name and all the point values and stuff. And what you can do is select the number of bullets. You can go, 0 through 4.
Oh, is that like a random?
Yeah, and so it's all random. That part of the game is all just programmatically decided.
Can I ask a follow-up?
Sure.
What's a peanut?
That is in the official game it's called a bomb. Kevin, when he was growing up, called it peanuts because they look like peanuts, and we decided to keep calling them that because it's safer to talk about that on a plane than a bomb. So you can position. There's a quirk in the game that we discovered after crashing a lot that you can't. There's a certain area you can put these. You can't get them too close to each other. So I had to figure out how this grid worked. You can, if you've got stuff in the way, you can move this grid around. But you can only have one peanut per grid, and the program doesn't yet enforce that, but it'll crash if you try to run the game and collect peanuts in multiple spots. As a side note, I discovered some other way that I didn't come up with this myself, but the cool way to do this kind of collision detection, or to figure out what you're over, is to actually draw it twice. Draw it to the screen and draw it to another buffer where each pixel has a number representing what you're over. So that's how you can detect that. Like you can move stuff around. Like I can pick that up, move it around. I can control click and select multiple stuff. If I wouldn't keep erasing things, you can copy and so let's see if I can do multiple select. Move them all. It's got full undo throughout the whole program. So, any other questions? Yeah.
So, if you wanted to add comments to disassemble the code, can you share that with somebody? Like, would there be an easy way if you had a couple people collaborating on, disassembling a game or something? How would you do that?
Like synchronization? There's no.
Not even synchronization.
Oh,
just
okay.
the file format or.
Yeah. So I save it out. All the data is saved out in a JSON format, and it's saved as a separate file. So where is it? So there's a separate file that you can ship along with it that'll get loaded up automatically. So that's how Kevin and I were sharing stuff back and forth.
And is that how you dumped out your the actual code with the comments for your final document that you're?
Oh, that was just a Google Doc that we just kind of we shared. So there's more stuff in the Google Doc than in the comment file right now. But yeah. Any other questions? Yeah, so I will send a URL to the KFest list, and I've made a few changes since I've been here, and I can't build on Mac or Windows here, so the official release won't be till I get back home and can build it. But also, I forgot to announce that Kevin and I started a contest. We're trying to gather up 32 new levels to make a new version of Jumpman. So we'd love it if we had some KFest participants. So I'll send out a link to that info and stuff. We're just going to gather them up, and I think the deadline is August 20-something. So we have a couple months to do something. But we'd love to have some Apple entries with little apples all over them, or if somebody want to create a load runner version, a little load runner level, that'd be great. See if we can figure out the custom code. That's our next step. We're going to work on that, and we'll publish that as we go. But we'd welcome entries. So, anything else?
Your HackFest entry to finish my HackFest entry.
I'll give you a copy. Sure.
This is a sort of a tough question, but so you're recording somewhere in a JSON, or exporting at least in a JSON file, the comments that you have on the code.
Yeah.
What is the sort of grain size of the thing that it's associated with? Is it a disk? Is it part of a disk?
Okay.
a file on two different disks to know to associate the JSON with it, or like I guess I'm just kind of
It's
curious.
yeah, it's basically.
Summarize the poster drop for the demo.
Oh, sorry, yeah. So the JSON file is associated with what essentially? Is it a disk level? Is it package level, multi-level? It's actually it is associated per disk, but it's also within that disk. It's associated with a segment. Oops. By default, it loads up anything it sees as Jumpman in the Jumpman level editor. So let me get to the hex editor. Ooh, nice colors. So it also associated with a particular segment. It'll if it knows that it's in a segment, it'll change all the sort of relative pointers to match that whatever segment it's in. I don't know. Is that?
Yeah, well, I guess I was just sort of thinking that it's possible something could span disks, or it's possible that the same file could be on different disks, and I'm wondering if the JSON could track it anywhere. Like I just didn't know what the.
Yeah, you can put. There's nothing in JSON that links it to a particular file, so you could use the same JSON and put it on multiple files. I don't have the concept of like a set of disks and tracking it together that way. But I could use this JSON file and stick it on another Jumpman, and it would pull up with the same comments. But yeah, no, I don't have a like a set at all yet. Other questions?